Hello everyone, my name is Kenji Kazumura. Today I talk about microservice specifically for the enterprise system, which usually require robust and reliable quality. Who am I? I'm working for Fujitsu for several years, and I'm responsible for development of Launcher, which is an implementation of MicroProfile, and Enterprise Application Server, which is an implementation of Jakarta EE. I'm a member of some committee of Jakarta EE working group, and also a member of JCPEC. So today's agenda. First of all, I introduce the current status of microservice on the enterprise systems. After that, I provide some guideline how to make a robust system with microservice. And then I will show some demos with MicroProfile and Istio and some tools such as Grafana or Kiali. So this is the Jakarta EE Developer Survey. One of the questions is, what architecture approach do you plan to use for implementing your Java system in the cloud? And 39% people answer microservice, and 23% answer hybrid. I think these numbers are not bad because the target of this survey is developers. But in reality, there is not so many microservice systems in the enterprise mission critical area. So I think the enterprise people are usually conservative and they are reluctant to adopt a new technology. After the technology are matured, they start to use this technology to their systems. So in case of microservice, reliability is one of the key points for the adoption in the enterprise system because the existing system is designed the concept that failures should not happen. But on the other hand, microservice is designed for resilient on the failures. So there is a gap between the existing service and microservice. And we need to bridge this gap. So how do we make service robust? When considering the reliability in microservice, we should know the importance of each service is not the same. That is, some services are required very high SLA, but some are not. That is, you need to distinguish which services are important and which services are not. And one more thing to be considered is when adding new service, this service must not affect the existing system, specifically the high SLA service. So, given these considerations, when using microservice, I think there are 3 points to be considered. First one is relationships among services. As I mentioned in the previous slide, when something wrong with one service, you need to know which services are affected by the bad service. And you need to isolate this bad service. And the second thing is I recommend to use fault tolerance to each service. But the problem is it is very difficult to find out the best value of the parameters of FT because FT provides a lot of features and a lot of parameters, and it is difficult to find out the proper values. If you do not set the proper values to the FT, the system getting worse. And third one is observability. So the only setting the fault tolerance is not enough. You need to keep looking at a lot of metrics of service, and the system is working well with your setting fault tolerance parameters. So here, I pick up three major fault tolerance features: timeout, fallback, and circuit breaker. So when you use timeout, so you can use the timeout for the service which requires timely response. And if the service has no alternative method, you should use just timeout. But in case of fallback, the service has some alternative method, alternative service, you should use fallback. And circuit breaker, if the service has no alternative, and this service may affect other service, in such a case, you should use circuit breaker. So I will explain more details with a concrete example, food delivery system. This system is not a real system. This is a fake system and available only this session. This system provides the customer the food and delivery the food to the customer. First of all, customer log into the portal service. And the portal service asks account service. And if something wrong with account service, we just time out because this service has no alternative. So we just sorry page to the customer and just time out. And the customer ordered the food, for example, burger or pizza or whatever. The portal service requests to the order, and order dispatch the request to the each shop's burger or pizza, depends on the customer's request. And the shop service, such as burger service, requests to the delivery company. So there are some choice, and for example, broomstick or Duke Pike. And here we can use fallback. For example, if a broomstick has something wrong, in such a case, burger's service switch from broomstick to bike because the customer doesn't care which delivery company delivers the food. So in this case, we can use fallback. But here, we cannot use fallback because, for example, if something wrong with burger's system, we cannot change from burger to pizza because the customer wants to eat burger but not pizza. So in such a case, we cannot switch from burger to pizza. In this case, we should use circuit breaker. And we use this system for the demonstration. I will show the way to observe the service status by using Grafana or Kiali. And I also show how fault tolerance value affects the service. And in this demo, I use MicroProfile and Launcher, which is an implementation of MicroProfile. So I use 6 services in this demo: portal, order, burger, pizza, broom, and bike. And each service has an entry point. And these services communicate each other by a REST API. To simplify the demo, the customer specifies only 2 parameters: shop name and food name, like this. So So let's look quickly the program code for this demo program. This is a portal service. And there are two metrics here, burger timer and pizza timer. It is for to measure the response time of burger service and pizza times. I will use this metrics later in this demo. And what is doing here is just call the order service. Order is REST client. And before calling the order, the timer start, and after the order service, timer stop. And next, order service. This is also just calling burger service or pizza service. It depends on the customer request. And burger and pizza are REST client. And burger service is, and burger service also just call Duke Bloom. This is a REST client. So the program is very simple. Each service calls the other service by a REST client. So, and these 6 services are running as Kubernetes pod, bike, Bloom, burger, order, pizza, portal. And also Istio service also running as the backgrounds. So I use 6 applications and Istio. To order the food, use HTTP request like this. For example, shop equal burger and food is hamburger. So, and response is like this. Burger Queen accept the order hamburger and Duke Bloom delivered. And if you want to order the pizza, it's similar way. So you specify pizza and margherita. And response is similar response. And next, I show you the QRE window. Display and hide name is unknown. Unknown is Prometheus service, so I just ignore this. This is a QRE window, and so you can see you can understand the relationship of the mic service with this kind of graph. So portal call order service, and order service call burger or pizza, and the burger service call Bloom. So you can easily understand the service relationship. Okay, next, I put some bug intentionally here. I put some bug in Broomstick program. Like this. So every 3 times, it's randomly, it sleeps 5 seconds. And I put the timeout and callback, timeout 1 second and callback. So fallback class is here, and it's simply called Duke Bike instead of Duke Bloom. And let's see what will happen. But before that, in order to see the metrics, I set up the Grafana dashboard and add panel. And first select the metrics, application and burger time mean. So this is the average time. Set gauge. So this matrix is I created in the application here, this matrix. And here, and one more matrix. Application and burger timer second. This is a percentile information. Set gauge and plus value. Okay, and let's see what will happen. So in this case, I use some script to call the burger service. In this script, just call burger service repeatedly. So let's do call burger service. So if you see some requests use Duke Bloom and some requests use Duke Bike. And first, look the QRE Console. Okay, so you can see burger service request Bloom, but in addition to that, burger service request also bike service, because some requests are timeout and burger service request to the bike as a fallback. And let's see the metrics. Okay, the average of the response time is 0.36 seconds. It's not bad, but when looking at the percentile information, this is 99.9 percentile, and this is 99.99%, and this is 98, and this is 95, 75, and maybe 50 percentile. So if you look at the percentile, it's almost 1.1 second or 1.3 second. And this is expected behavior because I set 1 second for timeout. So this is expected result. So the question here is, what value should we set for timeout? The answer is, first of all, you need to set SLA or SLO to this service. And if you don't care the percentile information, you just look at the average time and this value, and to see if this value satisfies the SLA, your SLA or SLO. And if you care about percentile information, you need to also this kind of information, and you adjust the timeout value until the response time satisfies your SLA. So next time, I put another bug into here, pizza. But before that, I debug the bug. And I debug the fault tolerance feature. And in this time, I put the bug into the pizza service. So in this case, every 2 times, randomly sleep 10 seconds. And at first, I just put the timeout and retry. And let's see what will happen. And before request to the system, I put another matrix. So select application, and this time add pizza matrix, pizza time mean. So this is the average time. And one more matrix application and pizza second. This is the percentile information. Okay. Okay, and in this time I use the other script like this. We call two types of HTTP request. One is for the burger and one for the pizza, and call repeatedly. And let's see what will happen. So let's see the metrics. So it's getting time to reflect the metrics. Yeah, okay. Yeah, and the average of the response time is 1.4 seconds and 1.2 seconds. And it's a little bit fast, but the problem is here. If you look at the percentile, it almost 2.8 seconds or 3.3 seconds or 3.8 seconds. But it is okay because pizza service has a bug, and this result are expected. But problem is here. Burger response time also very bad. Although burger has no bug, the response time is very bad. This means that pizza service affects the burger service. In this case, we should use circuit breaker. So the meaning of these parameters is 25% of 4 requests failed, the circuit become open. And when the circuit is open, the request do not wait. Instead, return immediately with circuit breaker exception. And other service catch the circuit breaker exception and return to the service unavailable code. This is 503 is HTTP code. So let's see what will happen. And clear the matrix. And again, request. So let's see first QRE Console again. Okay, so you can see here some of the requests returned 5xs code because circuit breaker exception thrown. And let's see the metrics. Yep. Average time is getting better, and still pizza has bad number, but it's okay because pizza has a bigger, and burger response time is getting better. So in this situation, we understand the circuit breaker is very useful. So wrap up. Higher reliability of microservice is necessary to be succeeded in the enterprise market. And one of the key for the enterprise microservice is observability. And MicroProfile and Istio and some tools such as Grafana and Kiali provide a way to observe microservice. And this is the end of my presentation. Thank you very much. So we have 3 minutes for QA. Any question? No question so far. Is there any audience? Yes, okay. Okay, so I show you some the reality of the enterprise microservice situation. So thank you for participating in my session. It's a great pleasure for presenting in XCon 2020. Thank you very much. Bye.